All right. Well, I have some venial sins to address here and conflicts of interest. As Matt mentioned, we're going to just talk about this one article that actually claims that there will be a million cancers every decade caused by CT scan. Now, radiation therapy is terrifying. When I was 8 years old, I read Dick Tracy, and little wings had been exposed to radioactivity and may lose a leg. So even in childhood, it was invisible and it's terrifying. In high school, I read On the Beach, again, horrified. And most recently, Annie Jacobson's Nuclear War. This is very, very scary stuff, and some people exploit it. Does ionizing radiation cause cancer? Absolutely, yes. We've known this with empirical evidence, and I'll use the word empirical evidence a lot, that radiologists got fluoroscopy cancers, radium girls got oral cancers. Radiation therapy, by 1950, we knew that radiation therapy for cancer caused lung cancers. Atomic bombs cause lung cancer, and probably nuclear reactor accidents cause it. But what about low dose radiation? Those are all high dose radiations. Paracelsus said that all things are poisons, and for there is nothing without poisonous qualities. It's only the dose which makes a thing poison. That's the principle of toxicology. Well, the first one to say that small doses cause cancer was David Brenner at Columbia University, to the best of my knowledge, in 2001. And he emphasized children. But in 2002, he predicted 36,000 lung cancers caused by CT screening. And David Yankelevich responded to that. Perhaps he can weigh in on that later. The NCI jumped in 2004 with Amy Barrington de Gonzalez talking about CT scans causing more harm than good. David Brenner again in 2007, now talking about 1 to 2% of cancers being caused by CT scans. Barrington Gonzalez got more specific in 2009, saying now there'd be 29,000 lung cancers. And here is Smith-Binman talking about 1 cancer for every 80 CT scans. And then Robert McCunney jumped in about 2014 with 3 articles in Chest talking about risk of radiation therapy in CT scans. And he talked about risks of radiation higher than nuclear workers, despite the fact that the average CT scan is about 1 millisievert. And finally, we get up to the article today that we're here to discuss, basically escalating this radiophobia. Now talking about 5% of all cancers will be caused by CT scans. Not only that, but there were some specific organ cancers that were predicted. For example, lung cancer and colon cancer, and we'll return to that. So remember those numbers. Now, these articles have been picked up by the popular press and reverberated. They've been picked up by critics of lung cancer screening, like Dr. Redberg, who's the editor of JAMA Internal Medicine at one time, and Peter Bach, who argued that we shouldn't screen low-risk people because of this radiation risk. Is there empirical evidence that low-dose CT scans can cause cancer? And the answer has to be yes. There is some data, but it's controversial. This is a study from England by Pierce in 2012 that found an increased incidence of brain tumors and leukemias in children who had had CT scans. And Brenner felt this was definitive. Others have not. The question is, can you extrapolate that putative increased risk in children to adults? As this is a slide from Brenner, by the way, which shows that not everybody agrees with him. Is there any empirical evidence for carcinogenesis with low-dose radiation in older adults? And the answer is no. That's not my quote. That's Smith-Binman. For adult exposures, direct estimates are currently unavailable, and to empirically quantify lifetime risk, we would require decades-long follow-up studies of very large populations. Therefore, we have no empiric evidence, and we're not going to have any empiric evidence for many years. So basically, all of this information is based on modeling and not on empiric evidence. Which model? Well, we're talking about the linear no-threshold model. Now, this model has been around for a long, long time, and it's Hermann Muller, who got the Nobel Prize in 1946. Now, a couple of things. 1946, we did not know that DNA was the genetic carrier of cells. And so he did radiation, relatively high dose radiation on fruit flies. So this is very crude research. Not only is it crude, but he's been accused of fudging his numbers. This article by Calabresi says that his graduate students told him they had made mistakes, and he did not communicate that to the Nobel Committee. Now, the problem, there's a lot of problems with this model, but the first one is that cells can repair radiation. This tree was charred in Nagasaki in 1945, and 80 years later, it's flourishing. It's a camphor tree, a beautiful camphor tree. High-dose radiation therapy shreds DNA. It produces double-strand breaks that are very hard for the cell to repair. But low-dose radiation causes many fewer double-strand breaks and much more easily repairable injuries. We know from a lot of research that the response to repair DNA from radiation occurs instantly, and within 10 seconds, there are dozens of different systems that are working on it. And we know empirically that a 100 millisievert dose of radiation therapy is rapidly repaired and is almost completely repaired within 72 hours, as opposed to higher doses where residual injury is left behind. Now, this 103,000 people is an enormous signal. We should be able to see that signal in our data. And in fact, we can't see it. What we see instead is that the number of cancers in the United States, since these predictions were first made, have gone down by 4%, not up. So is the better question, perhaps, is are CT scans causing any excess cancers? What about specific cancers? Well, remember that Brenner said 36,000 lung cancers. He said that 21 years ago, and yet we're not seeing any increase in lung cancers. We're actually seeing a decrease in lung cancers. Same is true with colon cancers. Smith-Binman predicted 8,000 colon cancers, and yet colon cancers in the blue line are obviously decreasing statistically. Now, you could argue that this is a question of latency, that we're not seeing these cancers yet. But Smith-Binman says that the latency period of solid cancers is 4 to 11 years. Now, that's very different from what other people have found. So, for example, after radiation therapy for breast cancer, we don't see lung cancers for 20 to 30 years. Does that mean that CT scans are more carcinogenic than radiation therapy? So, I see the problem as not as a disagreement over the meaning of the facts, but as a manipulation of the facts designed to produce the disagreement. This is a quote from Copan dealing with breast cancer screening. Is there any such evidence in what we're seeing today? And the answer is yes. Smith-Binman has made some statements about no conflicts of interest with respect to Alara Imaging Corporation. That is, I don't believe that's accurate. David Brenner has asked for money from the tobacco industry on a number of occasions, and he was a task scientist. And Robert McConney was an expert witness for Philip Morris in screening, testifying against lung cancer screening. So there is considerable evidence, some of it damning and some of it superficial, that there are some outside factors involved in some of these publications. So in summary, multiple publications cite a high risk of cancer from low-dose radiation from CT scans in adults. The evidence is based upon an improbable model. The empirical evidence is absent, not minimal, but absent. Radiophobia has been used to stoke fear and to delay implementation and limit eligibility of low-dose CT scans for lung cancer screening. And the authors of articles have conflicts of interest with regard to personal income and tobacco industry associations. Thank you. If anyone wants to know more about the conflict of interest, we could discuss that perhaps in a question session. Thank you so much for inviting me.